this lesson, you will write matrix equations for systems of equations and solve systems of equations using matrix equations. How can matrices be used in population ecology? Population ecology is the study of a species or group of species that inhabits the same area. A biologist is studying two species of birds that compete for food and territory. He estimates that a particular region with an area of 14.25 acres, approximately 69,000 square yards, can supply 20,000 pounds of food for the birds during their nesting season. Species A needs 140 pounds of food and has a territory of 500 square yards per nesting pair. Species B needs 120 pounds of food and has a territory of 400 square yards per nesting pair. The biologist can use this information to find the number of birds of each species that the same area can support. The situation above can be represented using a system of equations that can be solved using matrices. Consider the system of equations below. You can write this system with matrices by using the left and right sides of the equation. So what was 5x plus 7y equals 11? And when they put that into a matrix, they have a coefficient matrix. So here are the coefficients. A variable matrix, there's x and y, and a constant matrix. The system of equations is now expressed as a matrix equation. So we're starting off just by writing a matrix equation. Nice. If there's no number written in front of the variable, the coefficient is 1. So we're going to have 1, 3, 1, 2 for our coefficient matrix. Our variable matrix is going to be just like theirs. We have x and y. And our constant matrix, we have 3 and 7. And that's all they wanted us to do on that one. We're done. Now the work begins. The table below shows the composition of 3 types of fabrics and cost per yard of each type. Write a system of equations that represents the total cost for each of the 3 fabric components. Now it's lovely that they gave us our data in a table like that. All we're going to do is change the percents to a decimal. So I've got 0.1 times the wool plus 0.2 times the silk plus 0.7 times the cotton equals the cost of 7. And on we go for the other 2. We're still in the just write the matrix equations portion of our will-do list. So all I'm going to do is drop off the variables and put brackets around it. Solving it's the more interesting part, but we don't have to yet, so we'll just do what they said to do. There's my coefficient matrix, and then my variables were wool, silk, and cotton, WSC. Wayne State College, maybe. And then our constant matrix. And that's all we're doing on those. Here we go. Use matrix equations to solve a system of equations. Okay, so first we need to write it, which is what we've already been doing. So we've got 5, 3, 4, 7, and xy equals 13, negative 8. Now, normally we undo what's ever happening to our variables. So we want to multiply both sides by the inverse of this 5, 3, 4, 7 dude. Okay, when we find the inverse, it's 1 over the determinant. So 1 over 35 minus 12 times, and the guys going south having a good time, they do-si-do. Those of us stuck in the cold north are freezing. We just change signs. And I'm copying down my other part. Now, of course, 35 minus 12 is 1 over 23. So I just wrote that nicely as I copied this over to the other side. We're going to go row by column when we multiply. So we've got 7 times 5 is 35 plus negative 3 times 4 is negative 12. And then first row, second column. 7 times 3 is 21. Negative 3 times 7 is negative 21. Nice. And then we're starting over, second row, first column, so negative 20 plus 20. And second row, second column, negative 12. And 5 times 7 is 35, plus 35. The other side's nice. When we go row, column, we're going to have a 2 by 2 times a 2 by 1, so we're going to end up with a 2 by 1. So we've got 7 times 13 is 91, plus negative 3 times negative 8 is positive 24, and negative 4 times 13 is negative 52, 5 times negative 8 is negative 40, and, oops, put the bracket in the right place, and all we have left to do is our adding and subtracting. Okay, so on the left, 35 minus 12 is, 23, seen that somewhere before. And 23, seen that somewhere before. Oh, I left off my xy, didn't I? And adding and subtracting over here, 91 plus 24 and negative 52 plus negative 40. Okay, so on the left, I have something that looks an awful lot like the identity matrix. So if I multiply row by column there, I'm going to get what I started with. That's nice. And on the right, 115 divided by 23 is 5, and negative 92 divided by 23 is negative 4. So I end up, all of that to say, we've got x equals 5 and y equals negative 4. Or we could just write as an ordered pair, 5, negative 4. Now, honestly, I don't usually write all that stuff that I did on the left because I know that's going to be just plain x, y. So I'm going to do this the lazy way that I usually do. Okay, there's our matrix equation. That's no problem. We know the left side's going to be just x and y. Okay, so I want to get the determinant of the matrix I have on the left. So I've got 10 times 3 is 30 minus 5 times 6. Oh, rats. I was going to do a whole problem, and guess what just happened here? I got division by 0, so that won't work. And I can see why. If I solve both these equations for y, I'm going to get a slope of negative 2 both times. So we have inconsistent solutions, parallel lines, whatever you want to call it. Okay, let's look at another one that actually works, because that was kind of pointless. So if you write our matrix equation, there's my coefficient matrix, my variables, and my constants. Okay, I normally just call it on the left side and go, hey, I'm going to get x, y. So I'm just going to work with the right side, which, an algebra book isn't going to do, but that's really all we need. So I need 1 over the determinant of that bad boy. So 3 times negative 2 minus 4 times 1. And then we've got our do change signs number. And we're going to take that times our negative 10, 10. That's all we really need to get the answer. So I've got negative 1 over 10 times. Okay, when we multiply, we're going row by column. We only have one column, so that's lovely. Negative 2 times negative 10 is 20 plus negative 40. And negative 1 times negative 10 is 10. And 3 times 10 is 30. And of course, 20 plus negative 40 is negative 20. And 10 plus 30 is 40. When I multiply them both by negative 1/10, which is the same as dividing by negative 10, I get 2 and -4, which if I'd written out all of the stuff on the left would have equaled xy. So my ordered pair is 2, -4. A system of equations can be written as a matrix equation in this form. To solve a matrix equation, find the inverse of the coefficient matrix and multiply each side by the inverse. So x equals the inverse of A times B.